we know, Avery, that a squared plus b squared is equal to c squared. And so that only applies for right triangles. However, we could also use the Pythagorean theorem to figure out whether a triangle is obtuse or acute. For example, if c squared is greater than a squared plus b squared, we know we have this situation right here where we have an obtuse triangle. And that makes a lot of sense, because if c squared is significant, or if c squared is larger than a squared plus b squared, knowing what we do about the hinge theorem, then this angle has got to be greater than 90 degrees. So that should make a lot of sense. So again, that's going to give us an obtuse triangle.
Mr. Frampke?
Yeah.
Don't two sides have to add up to be greater than the third side?
Yes.
So if c squared is greater than a squared plus b squared, isn't it technically not a triangle?
No, because in this case we're squaring a, b, and c. And so when you square numbers, their difference gets bigger. For example, let's take 5 and 10. 5 and 10 are only 5 spots away on the number line. However, 5 squared and 10 squared, well, that's 75 spots away on the number line. So by squaring the numbers, you could end up with a situation where a squared plus b squared, I mean, that triangle theorem doesn't work anymore, right? Because squaring is not the same as just having 3 numbers. Now, the same thing can be said about acute triangles. And let's call them A, B, and C. So I'm going to call this side big C, this side big B, and this side big A, because we're across from each angle. And so we can also say that c squared, if c squared is less than a squared plus b squared, we know that we will end up with an acute triangle.
A cute little triangle.
That's right, a cute little triangle. Not the ugly ones, the cute ones.
Both a's are lowercase.
Yeah, well. Much better. Okay, so then that is called the Pythagorean Inequalities Theorem.